Hi, my name is Hamid Fatih. Welcome to my channel. Today, we will explore the solid principle, 5 fundamental design principles that will transform how you write C# code. These principles, introduced by Robert C. Martin, are essential for creating maintainable, scalable, and robust software. By the end of this video, you will understand each principle and see practical C# examples that you can apply immediately in your projects. Let's dive into each one with C# examples, and I will explain them one by one. First is S, single responsibility principle. It means a class should have only one reason to change. It should have only one job or responsibility. So I have a report class here, but as you can see, it generates report. Also, it saves to file. So 2 responsibilities for one class. How can I fix this issue? So I can define 2 separated classes, one report with just generate, and the other one file report saver just for saving. I just use numbers for the name of classes because I want to have all in one class. So report number 2 is just responsible for generating report, and file report saver is just for saving into file. So you can create, for example, database report saver or anything else based on the output you want. But what if I want to call generate and save in one method? So at this specific scenario, I can create another class as a report manager, something like this, and then I can use report2 and file report saver and pass them to constructor, and then call create and save report, and then define create and save report with generate and save. But still, this class has an issue which related to D in solid, dependency inversion. So let me show you a better example of this class, but we will discuss about it later. So instead of concrete types here, I should be able to use abstractions. So I can have something like this. I report for generating report result implemented by report 3. I report saver just for saving, and for this specific one for saving into the file. And then inside report manager, instead of a concrete classes, I can use abstractions. So as you can see now, I work with iReport and iReport saver, and this time dependency injection can help me to create a valid instance based on each abstraction. So now, instead of concrete types, I use protocols or abstractions. But we will see the same example when we want to talk about dependency inversion. O for open-closed principle. It states that classes should be open for extension, but closed for modification. You should be able to add new functionality without changing existing code. We have a discount calculator and calculate discount method which accepts customer type, and for each type has a if-else block and returns a specific value for that specific type. What if I want to create a new type and add ultimate type here? What should I do? I should change this code, and it violates open-closed principle. So we should change it to something better. What is this about? It's about discount. So what can I do? I can define an interface, as you can see, discount, and I return a double value for get discount, which is exactly based on our use case. And now, instead of each type, I have created a class, a separated class, which is implemented I discount and pass specific value. So now discount calculator will change to something like this. So as you can see, instead of a lot of if else, I worked based on interface and then use discount, which is part of that interface. So let's back to the definition. We should be able to add new functionality, open for extension without changing, closed for modification. So it means I should be able to introduce ultimate customer, for example, without changing this block. As you can see now, I have ultimate customer with a specific value here, 0.3, and I don't need to change this code. I just need to pass ultimate customer instance for this specific interface. L is for Liskov substitution principle. It states that objects of a superclass should be replaceable with objects of a subclass without breaking the application. We have a bird class. It contains it and fly. Why? Because bird eats and flies. But what about ostrich? Ostrich inherited from bird, but ostriches cannot fly. So it means as a subclass, ostrich, I cannot use it instead of bird. And in here, we are breaking the application because bird says, I support it and fly, but then in the subclass, we say, oh no, there is an exception. We cannot support it, which is wrong. So we should change this to something else. So I can move a generic part to bird class, and for a specific part, I can define interface. So bird number 2 will contain it, hopefully all of the birds it, and for flying, I define a specific interface. So now I can change subclasses to something like this. I have a sparrow, which is bird and flying, but for ostrich, it's just bird and its. So as you can see, now definition of ostrich equals to birds. So I can use ostrich with the same definition and replace it with the parent. So now it satisfies the Liskov substitution principle. I for interface segregation principle. It states that clients should not be forced to depend on interfaces they don't use. It's better to have many small specific interfaces than one large general purpose interface. For example, in here, I have iActivity contains work in it. For human, I just implemented it and it's correct because human works and it's. But what about robot? Robot works, but for it violates interface segregation because we forced robot to implement part of interface which is not necessary. So I guess instead of iActivity, I can create 2 smaller interfaces, something like this. Now I have iWork and iIt, separated 2 different works, and then I can use them for human and robot like this. Human implements iWork and iIt both, but for robot, I can just use iWork. Last one is dependency inversion principle. So it has 2 parts. One is high-level modules should not depend on low-level modules. Both should depend on abstractions. Abstractions should not depend on details. Details should depend on abstraction. This is the second part. So D for dependency inversion. Let's see how it can help us to make our code better. We have a light bulb. It contains turn on. And inside the switch, I created an instance and used the turn on inside the operate functionality. But it violates dependency inversion. Why? Because switch uses a concrete version of light bulb, but it should be depend on abstractions. If you remember, in single responsibility, I introduced you a better example. In here also, in Report Manager, we had two concrete types, and I changed them to relevant interfaces, iReport and iReport Saver. Exactly same thing here. So let's back. In here, now I want to define interfaces, an iDevice. So I have something like this. I move turn on to interface, and now light bulbs 2 implements this specific interface. So I can switch to something like this. So instead of call and use light bulb concrete type directly, I depends on abstraction. So I can use a dependency injection to pass a correct relevant instance to this constructor and then use turn on inside operate in this switch class. Last one is a big example. It contains all of the problems we need to tackle for Solid. So let's check together and find them and then write a better version which satisfies Solid principle. Okay, I have a notification sender here. It contains send email, send SMS, push notification, and a scheduled notification. Okay, as you can see, I guess there is a problem. If you remember, it's about interface segregation principle. So we should separate methods to a smaller interface and create multiple smaller version of them. The next thing is a notification service here. So as you can see, email sender and SMS sender are here. So I guess you know this violates dependency inversion principle. It's not good. We should use abstractions. And we have a send notification functionality. Again, it contains if and else stuff. So it violates open close principle. So we should take care of it. Also, I can see the same for send scheduled because it's not abstraction, it's a concrete type. So we should change this part too. And in general, I think notification service itself, the whole class, is against single responsibility. Why? Because it's routing notification based on type, managing different sender instance, for example, send email, send SMS, handling the scheduling logic. The problem is here. So this is the problem. We have a SMS sender, so no interface for it. We have a scheduled SMS sender. As you can see, the base class SMS sender says send SMS should be part of it, but says, oh, I cannot implement it because it's not part of my responsibility. So I guess it's against Liskov substitution principle. We have push notification sender, which is, as you can see, against the Liskov substitution principle because it doesn't implement all functionality in the interface. So for 3 of them, it just says, oh, I cannot implement them. So it's against the LSP rule. How we can use this class? We should create a notification service, and then based on that, we can call send notification. Also for a scheduled version, we should create another instance and call scheduled. Now let's back and see how we can create a better version. So I guess first thing is defining separated smaller interfaces. So as you can see, I have email sender, SMS sender, push notification sender, and scheduled notification sender. Each one has own responsibility. Then I can create concrete classes for each one. So I have email sender 2 implemented email sender. I have SMS sender. I have a scheduled SMS sender. This time, if you want to have send SMS and send a scheduled notification in one place, you can use 2 interfaces. For push notification, I just implemented a relevant interface, and also for scheduled, we have same. Next step is defining an enum. I want to have enumeration type for each email, SMS, push, and a scheduled way to send a notification. And the next part is strategy. I want to have a notification strategy. So I create an interface, notification strategy. It sends a notification and it handles this strategy based on the type. It checks this strategy is suitable for this type or not. Now, based on this interface, I want to implement the first strategy, which is email notification strategy. What is inside it? First, we pass email sender. So we are using abstractions. Then in send notification, which comes from notification strategy, I can just call send email safely, comes from this specific interface. And then in can handle, I can check the type passed is email or not. So as you can see, you can easily write a strategy for the rest. Let me show you. We have SMS notification strategy. This time we pass SMS sender and send SMS calls here, and notification type is SMS. Same for push notification and type is push here, and same for scheduled one. So a scheduled type here. So we are in very good state. We can change notification service and write it based on abstractions. So this is the code. So now notification service, instead of using concrete types, works with a list of notification strategy, and then inside, based on the type you pass, can select one strategy and call send notification. So let me back to the program.cs, and in here I can do something like this. So I can create a list of the strategies. So in here I have email, SMS, push, and schedule the strategies, and then pass them to notification service 2. And now, based on the type I pass, I can send a specific notification. That's it. If you found this video helpful, please hit the like button, subscribe for more coding tutorials, and leave a comment if you would like to see more. Thanks for watching. I will see you next time. Take care and goodbye.